Hey everybody, this is Mr. Beckstrom, and today I'm going to go over an example from section 8C, and this one says a student is 20 years old and the world has a population of 6.1 billion. Assuming that the population continues to grow at an annual rate of 1.1%, predict what the world's population will be when the student is 52. All right, so the formula that we want to use here to find the population after the student is 52 is this one. It's going to say the new value, and this is in section 8C, is equal to the initial value times 2 raised to the power of little t over t double. And it doesn't matter too much how you write it as long as you understand what they're asking for. Alright, so let's try to figure out what our variables are. So we need to find out what the initial value is, what the t is, and what the t double. Now the initial value, that's the initial one that they give us, so that's going to be 6.1 billion, B-I-L-L-I-O-N, and we're going to multiply that by 2 raised to the little t is the amount of time that it's been. So if the student started at 21 years old and they ended at 52 years old, we can just take 52 minus 20, which is 32. That means it's been 32 years. So that's going to go on the little top there. So 32 years goes up here. And then on the bottom of that exponent, we are going to need to find out how long it takes this population here to double, because that's the t double. And we have a different formula for that. And that is, I'm going to do this kind of off to the side here, but the t double is approximately equal to, we have kind of an exact equation, we also have an approximate, but we're going to use the approximate for this one, and this is in the section prior to that, it's an 8b, it's going to be 70, just the straight values, it's always going to be 70, over p. That's the percentage in the percentage form. So a lot of times with a lot of these formulas, we'll first convert to a decimal by moving the decimal place 2 to the left, but we're going to keep it in percentage form. So it's going to be 1.1. So that's going to be equal to just 70 divided by 1.1. So let's pull up the calculator. And that is 70 divided by 1.1, and that is 63 point. Now remember, while we're still working on a problem, we want to go out a lot of decimal places. So I'm just going to write 63.6 here, but what I'm going to do is in my calculator, I'm going to hit the Store As button, STO, and then I'm going to hit X up here, and then Enter. And what that does is it's going to store the whole number in here for X, so I can use it again whenever I want. For example, if I just hit X, Enter, it's going to give me that number back. All right, so that's the one that goes up here in this part of the exponent, 63.6. And now I'm going to go ahead and do all the multiplying. Now, there's a couple of different ways I can do this. I can either convert this just to a number with a whole bunch of zeros, right? How many zeros is this going to have? Well, it's going to have 6,100,000,000. So we're going to have 2 for the millions to make that 100 million. And then we're going to have another 3 for the thousands and another 3 for the numbers 1 through 999, right? So that's going to be an 8 total zeros behind this and moving the decimal place 9 places if we wanted to convert that to a number. But we can also just leave it like this, 6.1 billion, and then we can adjust it once we calculate that. So that's what I'm going to do here. And now I'm going to say 6.1 times 2 raised to the, and that's going to be 32 divided by, this all goes in the exponents, and I could put 63.6, but remember, I want to use a really precise value, so I either could have written down that whole number and put it all in here, or I can just put the x in there. And that saved that entire number in there for x for me. And I'm going to end up getting 8.64 from 6.1. So that means that my new population is going to be, new value, which is the new population, is going to be about 8.64. 8.64. Let's see how far they want us to round it. They said to the nearest tenth. So we will call that 8.6. 8.6. And sure enough, that is the correct answer. All right, I hope this helps. If you have any questions, let me know, and have a great rest of your weekend. Thanks.